Hello. My name is Mike, and I will be your narrator over the course of this wonderfully made video brought to you by Matthew and Lucas. First, we're gonna have a little talk about reflection. As you probably know, reflection is what you call it, when light bounces off of an object. This is what allows us to see things. If this is the case, why can't Matthew see his own reflection when looking into this brick wall? Well, that's because he's experiencing diffuse reflection. With diffuse reflection, light rays are still being reflected off of the wall, but they are bouncing off randomly, due to the wall being such a rough surface. If he wants to see his reflection, he will have to stand in front of a smooth surface such as a mirror, like Lucas here. That's the idea, Matthew. Now he's experiencing regular reflection. Light rays are bouncing off the mirror in parallel beams, allowing Matthew to see his pretty face. Reflection isn't the only phenomenon that can occur with light at a boundary. If the object transmits light, light will pass through it, and this is where refraction comes in. To give you an example of refraction, let's stick a pencil in a glass of water. Don't worry. The pencil is not broken. No pencils were harmed during the making of this video. This is simply the work of refraction. Have you ever tried to run in a swimming pool in the summer? Man, I swear, that water be slowing you down, don't it? Well, the same thing happens to light when it enters water, and this is why the pencil appears to be broken. You see, light slows down when it enters the water, and this makes it begin to travel in a slightly different direction. This alters the path of the light, causing it to bend. The light is slowed down this way because the water in the glass is more dense than the air that surrounds it. The dense water is like, whoa, just take it easy, man. Slow down, bro. And this causes the ray of light entering the water, called the incident ray, to bend, creating another ray called the refracted ray. There are two angles that matter to us here. Both are formed between one of the rays and the normal, which is an imaginary line perpendicular to the surface of an object. The angle of incidence is formed by the normal and the incident ray. And the angle of refraction is formed by the normal and the refracted ray. Why do we care about these angles, you ask? Well, that's where Snell's law comes in. This law states that the ratio of sine of the angle of incidence to sine of the angle of refraction is constant. The ratio of sine of the angle of incidence to sine of the angle of refraction is equal to n, aka the index of refraction. All materials have different indexes of refraction. Air's index of refraction is 1.0003, hardly refracting light, while water's index of refraction is 1.33. I hope you have enjoyed this video, and I hope we were able to shine some light on the situation. Huh? Get it? I said shine some light on the situation. Ha ha ha. It was a physics joke. About light. Never mind.